Hello everyone, this is Chinnaiah Kalpana here. In this video, we're going to see a problem from partial differential equation. So let's get going. Problem: form partial differential equation by eliminating the arbitrary function from z equal to f of bx minus ay. So here we are given an equation z equal to f of bx minus ay, and we are asked to form a partial differential equation by eliminating this arbitrary function f. Okay. Given equation z equal to f of bx minus ay, consider as equation number 1. Now we'll partially differentiate one with respect to x and also with respect to y. So first I'll partially differentiate one with respect to x. Okay, fine. I'll apply dou by dou x on both sides of 1. You can skip this step and do directly. This gives us dou z by dou x equal to, here we are partially differentiating with respect to x, so we'll treat y as constant. Partial derivative of f of bx minus ay with respect to x is f dash of bx minus ay into inner derivative, that is dou by dou x of bx minus ay. This gives us, since we know the notation dou z by dou x equal to p, so let's replace the LHS part by p. We'll get p equal to f dash of bx minus ay into partial derivative of first term minus partial derivative of second term. Okay, which gives us p equal to f dash of bx minus ay into, here b is constant, we'll write it as b into dou by dou x of x, okay, minus partial derivative of a constant with respect to x is 0, which gives us p equal to f dash of bx minus ay into b into partial derivative of x with respect to x is 1, b into 1 minus 0, no need to write 0 here, just write b into 1. Okay, fine. From this we'll get p equal to f dash of bx minus ay into b into 1 is b, or you can just bring this b here, then you'll get p by b equal to f dash of bx minus ay. We'll write this as p equal to b into f dash of bx minus ay, consider as equation number 2. Now let's partially differentiate one with respect to y. Partially differentiating one with respect to y. Just apply dou by dou y on both sides of 1. Since we are partially differentiating with respect to y, so we'll treat x as constant here. We'll get dou z by dou y equal to, here z is a dependent variable and x and y are independent variables. Okay, fine. Now we need to find partial derivative of f of bx minus ay with respect to y, which is f dash of bx minus ay into inner derivative, that is derivative of bx minus ay. Since we have a notation dou z by dou y equal to q, let's replace the first term, I mean the LHS part, by q. We'll get q equal to f dash of bx minus ay into dou by dou y of first term bx minus dou by dou y of ay, which gives us q equal to f dash of bx minus ay into partial derivative of a constant with respect to y is 0 minus here a is constant. We'll write this as a into dou by dou y of this y, right, which gives us q equal to f dash of bx minus ay into minus a into partial derivative of y with respect to y is 1. We can write this as q equal to minus a into 1 is minus a into f dash of bx minus ay. Consider it as equation number 3. Now observe 2 and 3. We have p equal to b into or b times f dash of bx minus ay and q equal to minus a into f dash of bx minus ay, right? Now we'll eliminate f dash of bx minus ay from 2 and 3 just by doing 2 by 3. p by q equal to b into f dash of bx minus ay by minus a into f dash of bx minus ay, where f dash of bx minus ay gets cancelled and we'll get p by q equal to b by minus a, right? Or you can write this as p by q equal to minus b by a, whatever. I'll just keep it like this and we'll make a cross multiplication, then I'll get pq minus pq equal to bq, sorry, minus ap equal to bq, right? Now, you can write this as bq equal to minus ap. Now bring this here, then we'll get bq plus ap equal to 0 or ap plus bq equal to 0, right, which is the required partial differential equation. Which completes the problem. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.